So with a calculator in my hand, I can work out percentages without going through the rigmarole we were going through yesterday. I absolutely stand by the fact that's worthwhile doing, not just because we have one non-calculator paper, but I want you to be a sort of person who is comfortable with working out percentages, and you can work out percentages quickly without the reach of a calculator. But in the majority of the situations, we will have a calculator available, and a lot of the time the percentages we're dealing with are quite fiddly percentages, like 57%, 1.5%. Those are fiddly percentages. So when you have a calculator in your hands, it could not be easier. All you do is you say, right, 43% as a decimal is 0.43. So to find 43% of an amount, I do 0.43 times that amount. Simple as that. Okay? 43% as a decimal is 0.43. So to find 43% of an amount, I do 0.43 multiplied by that amount. The word of in maths is often associated with multiplication. If I say, what's 2 lots of 3, you're going to do 2 times 3. So decimal equivalent, replace with a multiplication, stays as it is, bish bash bosh. Okay, can I get you to have a go at those ones there for me? Thank you very much. Okay, so if we could just pause. Do you notice with C, the calculator would have said 3.9, but because C was money, I'm going to write that with 2 decimal places, £3.90. And a lot of the time here we're dealing with money. Make sure whether you did 0.3 or 0.30 that you got that right, but whereas this was 0.04, not 0.4. So E, we've got 0.68 times 39, which was £26.52. F, 0.09 times 93, which was 8.37 kilograms. G, 57% as a decimal is 0.57. So that can't be right. Have I got that written down? Sorry, I've just got my answers wrong, I think. Sorry, yeah, so it's 1,824. 1,824. And then the last one, just make sure we've already come across that percentage in the starter, but for those that are watching at home, 0.015 is the decimal equivalent of 1.5%. Not 0.15, that's 15%, and that's 0.75. Any suggestions as to the answer to the last question? Go for it, Ed.
No, because it comes out as a decimal and you can have 0.44 of you.
Absolutely. If you do 0.17 times that amount, you get something 0.44. So it can't have increased by exactly 17%. Actually, no one's ever going to state the exact percentage increase, so it's probably valid to say it's increased by 17%. They've just rounded it, but no, you can't increase by exactly 17%. And that brings us on nicely to where we're really going with this, and that's percentage increases. So can I ask you for a little cheeky subheading at this point? So in these questions, we're talking about something which is increasing. First 6 are just without any context, and then we've got some with a context where we're actually told what it is that's increasing. So, for some reason, this amount, 40, has got 45% bigger. I could work out 45% of 40. I could do that with or without a calculator. It's not too hard, is it? And then add it on. But that's 2 sums, isn't it? Working out 45% and then adding it on. What if I told you we could do it in 1 sum? Would that appeal to you? Yeah. Certainly appeal to me. 1 sum rather than 2 sums, less work. Well, it just so happens you can. as long as you remember one thing, you always start with 100%. So this amount here is my 100%. So here we are, here it is. To that, I am going to add 45%. So Ben, what percentage do I now have? 145%. Cody, what is the decimal equivalent of 145%?
1.45.
1.45, fantastic. So I can get the answer to this problem in one go by just doing 1.45 times 40. And that gives me my answer straight away. I haven't got to work it out separately and then add it on. You just get the answer just like that. I call this the multiplier. The multiplier you need to use to increase something by 45%. It's 1.45. Easy peasy. Can I ask you, just humour me, can you draw me that diagram for that, just that one? I mean, if you want to draw diagrams for all of them, that's brilliant. But just so you know why we're multiplying by 1.45 rather than 0.45. And the answer is 58. So I haven't got to do any, I haven't got to then add that on or anything. That's my final answer. It's my final answer because I've done it all in one go. I haven't worked out 45% separately and added it on. I've just said, right, if I start with 100%, I add on 45%, I've got 145%. So I just need to work out 145% of 40, and that's how I do it. Okay, can I invite you to whiz through those? I'm sure many of you will remember that this is actually just revision. You will have come across this before, but it's worth doing again. It's worth revising. Right, so how easy is this? Okay, one single calculation where if I want to increase by 2%, I don't work out 2% and add it on, I multiply by 1.02. If I want to increase by 60%, I don't work out 60% and add it on, I just multiply by 1.6%. And etc., etc., etc. Increasing by a percentage with a calculator in front of you is easy. We use a multiplier. So this is what I'm referring to as a multiplier. And eventually we're going to get onto the higher sort of tier questions where very often you are asked what multiplier, and it's in situations where there are lots of changes happening, not just one change. Today we're just talking about one change. Just a quick turn and talk opportunity. Let's say we've got an amount of money and we increase it by 200%. And James said 200%, that means it's doubled. Is James correct? If something increases by 200%. Quick turn and talk. See if you can decide. Okie dokie. 3, 2, 1. Is this just something that's doubling? What's happening at? It's actually tripling. Yeah, it's counterintuitive, isn't it? Counterintuitive means something that's perhaps not what you'd expect. Yeah, I think it's very easy to look at that and say if something increases by 200%, that surely must mean it's doubled. But no, if it increases by 200%, you've actually got 300% of what you started with, so you multiply by 3. A 100% increase means doubling. A 200% actually means tripling. So, there you go. Okay, so that's percentage increases. Would you like to guess what my second little cheeky subheading today is going to be? Percentage decreases. Percentage decreases. Could I ask you to do that for me?
So can I do it now?
Yes, you may then. Right, let's retain our focus though, please. Thank you. Cody, are you doing that little subheading for me? Okay. So I could, if I wanted to decrease £80 by 18%, I could work out 18% and then subtract it. Two sums, much better to just do one sum. And you can, provided you remember one thing. Start with 100%. So, for my first example there, I start with 100%, and this time I'm taking away 18%. So Libby, what does that leave me with? I had 100%, I take away 18%.
82.
And Scarlett, what's the decimal equivalent of 82%? 0.82. So if I want to decrease something by 18%, I don't find 18% at all. I find 82%, because that's what I'm left with. After it's gone down by 18%, 82% is what I'm left with. So I do 0.82 multiplied by the amount I started with. Now listen, there's one thing that people find themselves almost unable to resist with decreases. There's something in us that says multiplying makes it bigger, so I want to make it smaller, so I need to be dividing. But that's not true. Multiplying can make things bigger or smaller, depending on what you multiply by. If I multiply by a number bigger than 1, then obviously I'm going to end up with a bigger answer. But here I'm multiplying by a number between 0 and 1. This is going to give me a smaller answer. So we multiply, we still multiply, but I'm not finding 18%. If I want to decrease something by 18%, I ask, what have I got left? In that case, 82%, so I've multiplied by 0.82. That is my answer straight away. As before, if I get you to copy that one example, and then have a go at the remaining 5 at the top there, and then this is just a mixture of increases and decreases where you've just got to match it to the answer. So it's not a mixture of increase and decrease, it's a mixture of all three things we've done today. Finding a percentage, increase and decrease. So, but do those top ones first, they are all decreases. Notice the vocabulary varies, doesn't it? Reduced, decreased. Okay, so if we can just check our answers. So for B, we should have multiplied by 0.8 or 0.80 because we were left with 80%. For C, we should have multiplied by 0.95 because we were left with 95%. For D, we should have been multiplied by 0.65 because we were left with 65%. For E, we should have multiplied by 0.3 or 0.30 because we were left with 30%. 100% take away 70, it's what you're left with that we're interested in. And for F, 100% take away 4.5 is 95.5%, and that's 0.955. So with all of these decreases, we're multiplying by 0 point something, because we're ending up with less than we started with. this wasn't an increase or a decrease, so you should have just done 0.78 times that amount. This was a decrease, so you should have done 0.92. This was an increase, you should have done 1.24 times 60. This was a decrease, 100 take away 90, you were left with 10%. So it's just 10%. Hopefully didn't even need a calculator. Here's one of those odd ones. Start with 100, increase by 120, you've got 220%. So you multiply by 2.2 or 2.20, means you've got more than double. And then this wasn't an increase or a decrease, so you just multiply by 0.95. Okay, so let's now start to shift into more than one change happening. Okay? %35 decrease followed by a 10% decrease is not a 45% decrease. Can you have a little chat to try and decide why it's not a 0.45%, sorry, it's not a 45% decrease. A 35% followed by a 10% is not a 45% decrease. See if you can discuss for 30 seconds or more why that is. Why that is.
Well, I don't know how to explain it.
Are you offering me answers? Not at the moment, because I want you to hear this. Are you offering me an answer? Okay. Right, thank you. 3, 2, 1. Let's focus. Thank you for being earnest in your discussion. So go on, Phoenix. Can you explain why this is not a 45% decrease?
Because it's already on sale, so you take it down to, so you take that price off, it would be £780, and then you decrease it by 10% again, to be 702.
You're absolutely spot on. It's not, that second 10% decrease is not 10% of this, is it? It's 10% of the sale price. So it's not going to be as much as a 45% decrease of this, because that second decrease is only 10% of the new price. So when you've got these multiple changes happening, you have to do them separately. You have to do them separately. So firstly, Cole, what do I multiply by if I want to reduce by 35%?
0.65.
Brilliant. Now be absolutely clear if your Cole was right there, just like that, but please make sure you're clear why it was 0.65. We started with 100, we took away 35, we were left with 0.65. So we multiplied by 0.65. You'd already done that, had you, Phoenix? So what was that amount?
780.
We then want to decrease that by a further 10%. So Dougie, what are we going to multiply by to reduce it by 10%? Again, brilliant. Make sure that you're as confident as Dougie and Cole. 100% take away 10% is 0.9. And just to make sure you believe me, can I get you to work out that final price? Why not draw it with the bubble diagram? But then also look at what would have happened if you'd reduced that by 45%, just so you can see the difference. Okay, it's not a huge difference. It's not a huge difference. But do it properly. Yeah, why not? Why not? Do it properly, but then see what a 45% decrease would have meant. Right. So work out what it should actually be, and then do the 45% decrease just to compare, just to convince yourself that it's not the same. So if we'd just done a 45% decrease, we would have got the wrong answer because we're taking away too much. The 10% decrease was not 10% of this, it was 10% of that. So the two changes together are not the same as 45%. And if you remember nothing more this lesson, remember that when you have multiple percentage changes happening, you've got to work them out separately. You've got to work them out separately.